All right, welcome back. So, impacts, space debris heading towards Earth is inevitable. What can we do about it? How can we minimize the hazard that possible impacts present? So, this is how we do that. First, we need to identify threats in outer space. So we'll talk about how and what we're doing in that realm. Once detected, we can blow it up in space. But small pieces could become radioactive and rain down on Earth. Bad news. We can nudge it, try pushing the impact out of Earth's orbit. But we do have technology that can change the orbit of an asteroid. But if we do that, where else is it going to go? Evacuation. That's possible if we can predict the exact impact point, but impossible if it's a large impact, as there is no safe place. So if any of this sounds familiar, blowing up asteroids in space, nudging it out of orbit, evacuating, if any of this sounds familiar, because it's pretty much the plot of every sci-fi movie that deals with this sort of thing. Armageddon, they tried to blow up an asteroid, Deep Impact. They fail, and there's an impact. So in any case, but these are kind of the plot lines of these two movies. So, well, what are we actually doing? Well, in 2005, Congress directed NASA to evaluate the dangers asteroids present, and to give some sort of report on ways to divert those that are on the course for Earth. So basically, using kind of the plots from movies is what, like, oh, let's try that. So the U.S. created ATLAS, which is the Asteroid Terrestrial Impact Last Alert System. And it was put in place, and it said by 2020, by last year, it ought to be possible to find at least 90% of asteroids with a diameter of 140 meters, that's about 500 feet, or larger, that come close to Earth. Although close not necessarily defined. So ATLAS is our kind of early warning system. It was developed by the University of Hawaii and funded by NASA. It consists of two telescopes about 100 miles apart, which automatically scan the whole sky several times every night looking for moving objects. If you just have one telescope, that's trying to look at something with one eye. But when you use two eyes, you see things a little bit better. You see things binocularly. You can see things a little bit better, more focused, and you're able to pick out small movements. So that's why there's two telescopes. So Atlas will provide at least 1 day's warning for a 30 kiloton small town killer asteroid. It'll give us a week's notice for a 5 megaton large city killer, and 3 weeks notice for a 100 megaton county killer. So that's like Avondale, Phoenix, Maricopa County. Now these are rated in megatons, which is the amount of explosive energy that an asteroid would have as compared to something like an atomic bomb. For instance, the Hiroshima atomic bomb was a 15 kiloton device when it exploded. That's how much energy was released. So for a small 30 kiloton, that's twice the Hiroshima atomic bomb. 5 megatons is like 600 times that. 100 megatons is like 3,000 times that, or something around that nature. So it'll give us some warning. It doesn't do anything, but it just gives us warning. So this is just an example of one type of system scanning the skies. And there's multiple. So again, so we have Atlas 1 and Atlas 2. Kind of they're both looking in the same spot, but give kind of a binocular look at things. Under favorable circumstances, it can detect a 100-meter asteroid at a distance of about 40 million kilometers, which is about a quarter of the distance to the sun. A 10-meter diameter asteroid at 4 million kilometers. And so far, Atlas has discovered 437 of those NEOs, near-Earth objects, 45 potentially hazardous objects. So it's great we can detect them, so how do we stop them? All right. So Atlas is just one of a few detective, or it's one of the newer ways to detect asteroids. So it's kind of getting up and running. There are some other ones we'll talk about here in a couple minutes. But, if we can detect them, well, what do we do to stop them? Well, in comes DART. DART is the Double Asteroid Redirection Test. This is a mission, and it hasn't even launched yet, to see if a spacecraft impact could deflect an asteroid on a collision with Earth. So, in essence, they're shooting a satellite up into space, and they're going to crash it into an asteroid to see if that just slightly changes its direction. There's really not much to it other than a couple of tracking systems, navigation systems on it, and then just slamming it into this thing. It's a little over 1,000 pounds. It's going to be moving about 13,000 miles per hour. So it's going to produce a velocity change of the asteroid that it's going to hit by 0.4 millimeters per second, which would lead to a small change in trajectory, right? So if something's coming your way, and even though we just deflect it a little bit over time, instead of coming straight at you, the trajectory will be changed. So even though it's a small little shift initially, it will lead to a large shift of path. So the mission's target is Didymos B. It's a little over 500 feet in diameter. It's expected to alter the speed very slightly, very slightly, and change the direction very, very slightly. So Didymos is not an Earth-crossing asteroid at all. So that's why we're aiming at it. We didn't want to try this on something that could potentially, if we redirected it, it could just we might just redirect it to Earth. So the Didymos, it's actually a 2 asteroid system. I'll show you a picture of it here in a second. But it's not an Earth-crossing asteroid pair. There's no possibility that the deflection could create an impact hazard on Earth. The launch date is in November of 2021, so just before or after, right around Thanksgiving. And then it will impact in the year 2022, September 30th, and then again, we'll kind of see the deflection. So this is Didymos A and B, so this is Didymos B, and we'll see if it is deflected any, how much it is, how much it changes. So again, we're basically just slamming this thing into it. Fun. All right, so we can detect them, we can deflect them, possibly. This is the first test. So who oversees all this business? So who's in charge of all this? Well, enter the Planetary Defense Coordination Office. They ensure the early detection of potentially hazardous objects, PHOs, anything that orbits within 5 million miles of Earth, 30 to 50 meters or greater in diameter. That's kind of what they're targeting as far as what they're detecting as far as these PHOs. They track, kind of characterize, classify all these different things, and issue warnings if possible impacts may be imminent. They study strategies, come up with different technologies for, again, mitigating PHO impacts. And they do play a lead role in coordinating the U.S. government planning as far as any impacts are concerned. Now, this was established not too long ago in 2016, and this graph to the right here shows the time of discovery of asteroids underneath this PDCO, the Planetary Defense Coordination Office, in relation to their closest approach, which is less than 1 lunar distance. So let me move me real quick. So on this chart, you see that in 2020, the red is the most. So we detected 64 PHOs after they had already had their closest approach to Earth. So, kind of a little late, I guess, right? So less than 24 hours, so less than a day, we had 14. Up to a week before, 26. More than a week, 2, and nothing really beyond that. So we're still kind of catching them late to the game after they've already had their closest approach to Earth. All right. But again, that organization, that agency isn't that old. So let me move me again. So here's another asteroid discoveries by count. You can see the blue and the white are those Atlas that I told you about, the newer asteroid detection system, and they only make a small part of what is done around the world. What I do want to point out is this red and yellow. So the red, the Mount Lemmon survey, it's Mount Lemmon here in Arizona, in Tucson, Arizona. Catalina Sky Survey, also down in Tucson. So you can see, as far as back in 2020, Mount Lemmon survey actually detected more new of these PHO asteroids than the Atlas telescopes did. So this is the Mount Lemmon survey. There's a number of different telescopes on top of Mount Lemmon, which is just outside of Tucson. So there it is, just right outside of Tucson, so kind of northeast of Tucson. So Mount Lemmon and the Catalina Sky Survey, they kind of work hand in hand. But let me just tell you about the Catalina Sky Survey. It is a NASA-funded project supported by the Near Earth Object Observation Program under the PDCO. So this is the PDCO overseeing this one. It's based at the University of Arizona down in Tucson under their Lunar and Planetary Lab. And the mission is to discover and track near NEOs in effort to meet the congressional mandates set forth. In addition to identifying impact risks, the project also identifies potential targets for space flight projects. So, when we're flying through space, there's stuff. So if we're going to try and fly to Mars, based on the path that we're going, well, there might be stuff in the way. So this also kind of takes care of that. It kind of tracks everything. So, it's not just looking at impacts on Earth, but is there any issues if we fly out in space somewhere? Would we come across a path of some asteroid? So this is a fun little chart. So these are all the most recent asteroids that have come in close proximity to Earth within 1 LD, within 1 lunar distance or less. So this shows you in the past, this, when I'm making this, it's late October. So in the past, couple of weeks, we've had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 NEO PHOs that came within 1 lunar distance of the Earth. So that's relatively close. Now, most of these are rather small. Which is nice. All right. Most likely those would burn up in the atmosphere. Not much to worry about. But these are tracked, and you can see that they do get pretty darn close. So this LD lunar distance, they do get pretty darn close to Earth. Just to point out this one real quick, this is from actually this cool little website down here. You don't have to go to this one, but if you're curious, you can. And then I clicked on the object only because it was the largest of the ones here in the past couple of weeks. And there's a little simulation. This is just a screenshot, but it's a little simulation that lets you see the white path is the path of the asteroid. The blue is the Earth, and you can see how close it is relative to us. There's Venus and Mars, and I'm blocking it, but Jupiter's orbit's way out here. So again, these asteroids are coming from that area between Mars and Jupiter in the asteroid belt out here. So that's where this one comes from. So they don't have all of them on this one, it's just specific to this one asteroid, 2021 TT1. Not sure what that stands for, but that's what it is. All right, so we can detect them, we can do stuff about them. There's agencies overseeing this. There's multiple different entities scanning the skies. So hopefully we're safe. All right, we'll pause here. When we come back, we'll talk specifically about some meteorites in Arizona, some of the impacts that have occurred in Arizona. I'll see you back here in just a second.